So I'm really excited to see this presentation. This is discussing distributed mesh infrastructures with all of the tumult and turmoil that we've seen around the world. One thing that we know is that the network needs to be resilient, and finding new ways to interconnect people, aside from what we just think about of fiber, is critical. And so I'd like Sascha and I guess Josh King to come up here and present on this. Thank you.
Thank you. How's everyone today? Silent. Seriously, thank you all for coming out here. I'm actually used to speaking in DC to a bunch of Hill folks and White House people and State Department people, and I'm used to being kind of the geekiest person in the room, and now I feel like sort of like a Lilliputian nerd compared to the knowledge and expertise that's here. And this is why I've actually asked my technical lead, Josh King, to come in, because for all that I know about our work, he knows far, far more. And I have a suspicion that some of you may wish to dive into the weeds far deeper than I wish to go. Most of my work in DC is as a part of a, do I push this once? Pardon? No. And you can see I just go next to technology and it breaks. So I work at a think tank called the New America Foundation, where I'm vice president there. It's about 150 people, and about 50 of us are part of the Open Technology Institute, which I run. And you have to imagine a place, DC is completely swarmed. It's overrun by lawyers. And more importantly, it's overrun by lawyers that wish to play technologists. And so if you're wondering, like, why do they keep making these crazy decisions in DC? It's because, honestly, most of the time they have no idea what they're talking about when it comes to tech policy. And so into that space, the Open Technology Institute was created 5 years ago with a fairly simple plan, which was to bring technological acumen into discussions where all too little of it existed. You can see our mission statement there. And so we have sort of the traditional think tank arm of our work. This is sort of the wonkery. These are the people making white papers and holding convenings and working with people inside the Beltway on developing policy. These are the people that are going up onto the Hill and banging our heads up against various brick walls for fun. But also, and unlike any other think tank in this area, we have a field operations arm. And the field operations arm are the folks that are out in community deploying networks. Now, the project that we're going to speak about today very much lies at the center of these two areas, plus the tech development, the work that we do in-house to actually build open technologies of various sorts. And we have sort of two big research development tech projects. One is called Measurement Lab, which is available at measurementlab.net. And this is another network measurement platform that I founded with Vint Cerf back in 2009, I guess it would be. And we just actually surpassed about 700 terabytes of data, all licensed under a Creative Commons 0 license, so anyone can use it. And I, for one, am definitely going to pick up an Atlas probe and plug it in at the office and see if there's other ways that we might collaborate, because I see this all as a mechanism to inform key policymakers with empirical data, which is a very radical notion in a lot of the circles that I work. But I'm not going to talk about Measurement Lab today, because in fact what we're going to be talking about is Commotion. And Commotion began, in essence, about 13 years ago in my living room, where in my utter technical naivete, I invited a bunch of local hackers and system administrators and super geeks while I was living in Urbana-Champaign over for homebrew and pizza. and thought this was going to be a summer project to develop some sort of distributed ad hoc mesh system that we could all build over a large geographic area. Well, as you can imagine, it's now 13 years later. We're still building it, but it has in fact grown, far outpacing the size and scale of my living room, and now has a global R&D capacity. And whereas we began this project looking at it through the lens of how do we bring affordable connectivity to those that are under or unserved, and this would have been prior to the new millennia that we were beginning this. Today, the number one interest from folks like the State Department and USAID and Radio Free Asia is this notion that these exact same technologies have a different facet to them, which is distributed, secure communications in places where censorship, surveillance, monitoring is a major problem, or where the internet itself or communication systems like your cellular infrastructure have been shut off entirely. So that said, Josh King is probably one of the smartest technologists I've ever met. I first met him probably in my living room or at the Urbana-Champaign Independent Media Center in Urbana, and luckily enough I was able to convince him to pick up and move halfway across the country to join me in Washington, D.C. There are few facets of this project that he hasn't had a direct hand in, and it's no exaggeration to say there are few people on the planet, and maybe no one on the planet, that knows more about this project and a wide swath of different open source mesh technologies than he does. So I want to bring up my longtime co-conspirator to then take you through kind of an overview of Commotion and what it means and what we could do with these technologies, what we're working on today, and what you might be interested in helping us with as we continue to develop the Commotion Project.
Right. Hi. Presentation tag team style. It's actually the back of a pickup truck, I think. Yeah. So the Commotion Wireless project is something that that's based on a lot of work that we've been doing for years in the community wireless networking and open source mesh wireless networking space, and sort of building on a lot of the technologies that we've worked with a bunch of other developers on over the last few years. And where I see the really valuable purpose of this technology is in being able to push sort of education and innovation about network technology and into the hands of communities, and being able to make the edges of the network as redundant and fault tolerant as we try and make the core of the internet. And there are a lot of really great examples of networks that are built kind of from this grassroots level up. Like there's the Athens Wireless Metropolitan Network that covers most of metropolitan Athens and the surrounding area, and has 1,120 nodes and 2,900 client relays. Or GuiFiNet in Barcelona that has 31,000 nodes and 36,000 kilometers of links. Obviously, I got tired of drawing dots and lines long before I got to 31,000. But why don't we see those sorts of networks? Those networks demonstrate a lot of opportunities for this sort of technology. As being test beds for things like delay tolerant networks, being sort of dynamically disruption tolerant, being able to route around problems in the networks, and as test beds for local applications and new use cases for networks that communities come up with. Being able to use applications that exist only within that exist and operate only within a local community. We've worked with communities that come up with ideas that if they had their own local infrastructure, what would they use it for? Some of the examples that we've had are people who want to build wireless air quality monitoring networks because they live in a polluted neighborhood, or they live in a neighborhood that's underserved for connectivity, and so they want to be able to host their own local maps and community calendars. Or they have a need for an event or a protest or something where they need to be able to communicate amongst each other and distribute information, but no such easy-to-use infrastructure exists. And distributed networks like that can also be extremely tolerant to different kinds of disruption, either like natural disruption or to takedowns or to other sort of influences that might cause different parts of the network to fail. They're able to dynamically route around those sorts of problems. But if we see those sorts of networks in places like Athens or in Barcelona, why don't we see large-scale community networks, distributed networks like that in the U.S. that get built up from just interested community members? Well, there are a number of challenges involved in that, like the overall technical complexity of building a large-scale network. Dealing with scalability issues, a lot of these networks are based on Wi-Fi and other unlicensed wireless technology that doesn't necessarily scale all that well beyond a couple of dozen nodes. And most of these networks are built by people who are, they're mostly built by a bunch of German hackers who only use command line interfaces for anything and don't make any sort of interfaces that are very accessible to make it possible for a community that's interested in creating their own infrastructure, whether that's an activist community or just a neighborhood here in a city in the U.S. There are no real documentation or entry points for them to be able to build a network like this, to be able to start learning about networks and what they can use them for in order to add value to their own communities. So what the Commotion Project does is to try and take a bunch of these existing open source technologies and build their interoperability, build cross-platform interfaces for them, create planning tools. Like this is a community mapping tool that we've been working with some developers in Brooklyn on creating, called Tide Pools, that enables community-based mapping and planning of networks and interacting with their networks and resources on the network in their communities that allow them to take just installing it on a few devices, installing mesh networking software on a few devices in a room in order to build a small network, and being able to take that from the small scale to the large scale so that networks like those that exist in some of the examples that I gave in Europe are more attainable by engendering those sorts of tools and those sorts of planning skills in the communities that we work with, and allowing them to build local applications that can run on the network and be utilized for local purposes, so that in the event of disruption of internet connectivity or for purposes that are purely localized, the owners and operators, the community that runs the network, is able to have agency over those applications that operate on the network. So where we are now with that project is that we're engaged in lab testing of the software. The software that we have is designed to run on consumer grade and commercial grade routers, on Linux, Mac, and Windows desktop machines, on Android and iPhone mobile devices, to allow people to get their hands on networking technology, to be able to learn about it and to be able to plan out these networks as part of a learning curriculum that we developed through our work with domestic test beds for further testing of the software, and through a program called Digital Stewards, which is a train-the-trainer program that we operate in a lot of the communities that we work with. Digital Stewards is a 6-week training curriculum that teaches non-technical users everything from how networks work, different kinds of antennas, how to install software on routers, how to plan networks, how to install them on rooftops and in buildings. And by the end of the course, they have the basic tools that they need in order to be able to learn about and implement these localized community infrastructures in their own neighborhoods. And then we're working to select new sites where we can work with new communities and new neighborhoods internationally, so that we can roll that into our training program and our documentation, and build use cases for our software, so that we can get better translations and make it more applicable, and continue to extend its reach as far as training and ease of use to everyone, to outside of the U.S. Sorry, wrong button. So thank you. If you have any questions, our websites and email addresses are up on there, or if anyone has any questions.
Are there any questions? No? Can you tell us a little bit more about how this could be used in, I mentioned earlier stuff like current political situations.
Mm-hmm. Well, one of the things that we're working on is sort of making this a useful platform for people to be able to build out their networks for internet connectivity and local communications, so that in the eventuality that that in a political an Arab Spring kind of situation or something like that, where network connectivity gets shut off, that infrastructure is already in place and allows people to communicate locally, even if traditional means of access to the internet aren't available. And also to be able to make it easy to use things like mobile devices to create sort of smaller ephemeral networks, so that just being able to pass messages and photos and things like that in sort of a smaller gathering or in a protest or something like that, so that things like that can get distributed amongst a large number of people in a delay-tolerant fashion, so that if any one device or any one person loses or gets confiscated their device, that their communications, their pictures and media can get distributed anyway.
I'll just add to that after Hurricane Sandy, when all communications was out in the neighborhood where we had one of our test beds, that then became the mechanism, the way in which people were able to communicate locally. And so we accidentally, if you will, had sort of a real world test case of the disaster scenario where this kind of distributed mesh could exist and be useful to local community members. We obviously, the State Department's support that we've received is specifically focused on what happens in, say, in Egypt too, where the main infrastructure, the main internet connectivity or cellular infrastructure is turned off. Is there a mechanism that one can use in order to enable people to communicate in a distributed manner locally and continue to swap information, swap media, et cetera? I guess just last Friday, if you go to our website, we're talking about sort of what I will call the BART scenario, whereby we were testing interconnection amongst devices on a subway train that did not have any internet connectivity to see if it was possible in that kind of environment to have communications in a distributed manner. And you'll have to go to our website to see what we found out. But those kinds of use cases, abroad and domestically, are exactly what these kinds of technologies are incredibly useful for.
Keith Mitchell, DNSOARC. I think the objectives of your project are commendable, and it's great to see the progress on it. I am, however, very concerned about your IP addressing architecture. Is my understanding correct that you are reusing IPv4 address space that has already been assigned elsewhere on the internet?
Yeah, that is the case. But we're working to change that. So the reason for that is that at its outset, when I started developing the firmware that would become one part of the Commotion Project, was that we had a need from one of the communities that we were working in to be backwards compatible with an open source mesh routing firmware called Robin. And that was the routing scheme that the Robin firmware used. And so that's what we ended up using, not routing scheme, sorry, the addressing scheme that the Robin firmware used. And so that was what we ended up with as a default. My understanding is that the reasoning behind that on the part of the Robin community was that at some time those addresses may have been sparsely utilized. I don't know if that's actually like a valid reasoning, but it's something that we're actively working to change, and it didn't make it into our most recent release to change that as the default addressing scheme, but we'll make it into our next point release to move to private addressing space. We'd like to move in the direction of using all IPv6 on the backhaul of the network. It's going to require some additional testing just because we are aiming, like one of our mandates is to support so many different operating system platforms that there's a lot of different networking stacks and a lot of different software to test to ensure that it's compatible with IPv6. But at the very least, we're moving in the direction of changing to like all private address space for the next point release. Because yes, there is a problem.
Okay, thank you.
Hey, Chris Grundeman. I noticed on the challenges slide, cost wasn't one of the things that was listed, and I wondered if you can tell us, like, the examples in the European cities, how are they funded? How do these things come about?
They actually come about in a bunch of different ways depending on the network. So it's really interesting. A lot of the different networks have extremely different models of organization and extremely different models of funding. And I say organization both from a standpoint of people and from the standpoint of like how the network itself is managed. For instance, the network, the Athens network is almost entirely completely ad hoc collective where individual participants all purchase and own their own nodes, and there's a loose sort of like congress of node owners that form broad network policy, but it's largely unmanaged. But there's sort of the network itself, sort of the ethic behind it is to engender a strong sense of personal responsibility behind that, and mostly any uplinks. That network was actually founded before there was cheap available broadband access in Athens. So it was originally founded almost entirely as a local network without any sort of dedicated source of uplinks, and so that wasn't necessarily a requirement for their funding model to fund uplinks to the internet. Now they do have uplinks that I understand are mostly like donated or they're funded through donations. But there are other networks like one that I didn't mention because it's just in one city, and so it would have just ended up being like one big dot. But there's the Funkfeuer network in Vienna, Austria, that has about 600 nodes that cover most of downtown Vienna and a lot of the surrounding neighborhoods. And they actually have a very tightly controlled and managed network that they manage through a close association. They are whatever the Austrian equivalent of a 501c3 is, I believe. And they fund the operation of their network by running a micro co-location facility through their main fiber uplink. And they're actually able to make enough through the co-location fees to fund the upkeep and operation of their network. So there are extremely varying sort of methods for funding the networks, and something that we have a strong focus on is just in trying to build a toolkit of technology and documentation that's flexible enough that it can support a lot of these different organizing models. Because what we find is that different models of funding and organization and network management, different models work better in different communities. And so we just want to be able to support as broad a swath. I would say that generally speaking, hardware-wise and operationally, the costs of deploying one of these networks is probably significantly lower than deploying like enterprise class gear and trenching fiber. But it's, there are trade-offs there too, because you don't have gigabit capacity, generally speaking, either. But yeah, so different for different networks, I guess.
Sure, thanks. And then kind of a follow-up question to that. You had like a next step slide that went into, we were working on the software obviously, and then looking at kind of pilot projects to develop the software with, and then the training. Where are you actually at with that? Do you have are there pilot networks in the US that are doing this, and are there people that have been trained, and
Yeah.
where have you actually gotten on that?
So we have pilot networks in Detroit, in Brooklyn, New York, in Washington, D.C. We have spoken with a few other people who have started up small networks just by downloading our software off of the website. The platform that's furthest along right now is the routing firmware, so it's in that sense it's kind of traditional community wireless network stuff, like Freifunk stuff. So we have small testbed networks, 2 in Detroit, 2 in DC, and 1 in Brooklyn, that are all running our software and are being managed by community members in cooperation with us. So we're working with them in order to build out the networks. The Digital Stewards Curriculum Training Program, we're currently running that. I couldn't tell you if we've actually completed the first course of Digital Stewards, but we're running it in Brooklyn and in Detroit.
Thanks.
Hi, Greg Dendy with Equinix. You may have just touched on my question. I understand that your technology helps support the Occupy DC movement. Mm-hmm. Are there any successes or challenges around that you can discuss?
Definitely some challenges. A lot of the biggest challenges there were just practical deployment issues, and that was largely around the fact that at that point, still the router-based platform is kind of our flagship platform, and some of the other platforms like the desktop clients and Android and all of that kind of aren't quite as far along in their development cycles. But because of that, we deployed routers in, we donated routers to Occupy DC, but mostly the problems there were just around electricity, because we didn't have it was kind of a spontaneous thing, and we didn't have batteries and solar panels, and they were plug-in PoE routers that burn a lot of power, and they weren't really designed to. Main problem was that they were running it off of a generator that frequently went down because it ran out of gas, and so the network was just too unreliable for them to really make use of. But we got a lot of good feedback and from people who were able to use the network when it was up, and it shows the need that we need to, since then we've focused more on both the mobile clients and enhancing their capabilities, doing some upstream Android work to support that, and also focusing more on power consumption on solar and battery powered hardware platforms, things like that.
Let me also add that first week of October, there'll be sort of a global gathering of people from the community wireless realm. So if you point your browsers to wirelesssummit.org, it'll be in Berlin first week, right before Oktoberfest, for those that might be interested in such. But good twofer in Germany in that month, for sure.
Any other questions? Thank you.
Thanks, everyone.
Thanks, guys.